Welcome back to Stewart Science. Today we're talking about how to find and how to use the idea of density. Now, density is how much matter is in how much space. It's mass per volume. It's the ratio of how much stuff you can cram in a small space. So, for example, I have two objects. Now, they look like this one would be much heavier because it takes up a lot more space. But this one is hollow, and this one is solid. So they actually have the exact same mass. If I put these on the scale, they balance each other off because this one has the same amount of stuff in a lot more space. So if I put this in water, this would float and this would sink because this is much more dense. So the way we find this is by taking the mass divided by volume. The mass is measured in grams and the volume is measured in milliliters. Sometimes you might see this unit as kilograms per liter. That's the same number because there's 1,000 grams in a kilogram and there's 1,000 milliliters in a liter. So it's the same ratio that you're looking at. You might also see milliliters or centimeters cubed. Those are also the same unit. So let's talk about how to calculate it and use the equation that we find. So let's look at a few practice problems here. The equation that we're going to be working with looks like this. D equals m over v. D is density, m is mass, v is volume. So density is a measure of the mass divided by volume. Mass is measured in grams or kilograms, like I said, and volume is measured in milliliters or liters. So again, you might see this density unit as kilograms per liter. I'll usually use grams per milliliter. So that's how I kind of figure out which unit goes with which variable. D is density, m is mass, v is volume. Density is grams per milliliter, mass is grams, volume is milliliters. So let's try a few practice problems and then I'll give you a few tips and tricks. So the most basic kind of problem is when I give you a gram, which is mass, and a volume, which is usually measured in milliliters. And so when you use this equation, mass goes here, volume goes here, and so you just take your mass divided by volume. 630 divided by 90 equals 7. That's our number. You run that through a calculator, and then that's going to be grams per milliliter. Easy peasy, lemon squeezy. See that my face is in the way, but I'll cross it out. Grams per milliliter. Okay, let's try another one. The other style of problem is if I give you a density and a volume. So when I plug these in, I get 2.2 equals m over 11. Now, all I have to do there is a little bit of algebra, which is very easy to do. I need to get the m by itself, and I do that by multiplying both sides by 11. Just algebra. And so I end up with 44 equals m. And since I'm finding a mass, m, that's going to be measured in grams. Again, those first two are very easy. Now the algebra is a little bit trickier on the last kind here because, as you'll see, the variable will be on the bottom of the fraction, which is a two-step algebra problem. So I'll kind of show you some ways to get around this or what I would do. First of all, 8.5 grams per milliliter, that is a density. Then 127.5 grams, that is a mass. So when I set this up according to my equation, I get 8.5 equals 127.5 divided by V. That's an issue because, like I said, my V, my variable volume, is on the bottom of the fraction. And so to get that by itself, I have to do two steps here. The first thing I need to do is get it off the bottom of the fraction by multiplying both sides by v. So times v times v. So if I rewrite this problem, now I have v times 8.5 equals 127.5. So the first thing I had to do is get the v off the bottom of the fraction. I can't leave it there because then I'm solving for 1 over v, which that's not how math works. Now I can divide both sides by 8.5 divided by 8.5. That equals 15 milliliters. So if all of this is confusing, let me give you a sneaky tip and a pro tip. Sneaky trick and a pro tip. My sneaky trick is that I'm going to be giving you densities that are less than 1. Because then when you multiply by it, it'll actually get smaller. When you divide by it, it'll get bigger. So you'll feel like the wrong thing is happening with your numbers. Like I'm dividing, but it's growing. And so your instinct will be like, oh wait, I did something wrong. Or your instinct is going to be to divide by instead of multiply. So it's going to throw you all out of whack. It's okay. A density that's less than 1 just means that it's less dense than water. And so I'm going to throw those at you intermixed with ones that are bigger than 1. So sometimes your number will be 8. Sometimes it'll be 0.4. There's a big range. And that's okay because densities can be big or they can be small. You can pack a lot of stuff in a small space or take a little bit of stuff and really spread it out. So don't be alarmed if you see densities that are less than 1. That's okay. My pro tip, if you're trying to find volume and you keep screwing it up or you keep getting the answer wrong, use a different equation. Instead of using d equals m over v, if you just rearrange this equation using algebra a little bit, you get d times v equals m. If you use this equation for all of them instead, let me box that better. If you use this equation instead of this one, your algebra will never be confusing. So you'll just kind of go around all that hard algebra. This is kind of the first step that we did on the last problem. So if you're finding volume and you're screwing it up, just use this equation instead. It's the exact same equation, it's just rewritten using algebra. As always, this is Mr. Stewart. Keep learning no matter what.